Welcome back, everybody. This is our third class in JEE Mains previous year questions for chapter Current Electricity of class 12th. Before this, in this series, we have made several videos, and two of them actually are available on our YouTube channel. Again, name of channel is Point Basics, and there is a dedicated playlist for these type of videos, and you can find those videos and playlist on our YouTube channel's playlist section. We have also started similar series for NEET previous years, so if you want to check those out and recommend them to your friends, then you can also watch those videos. And at last, if you find these videos useful, then press the like button, share them as much as possible, and subscribe to our channel. Also, if possible, do make some donations by scanning these QR codes in front of your screen. With your donations, it help us to keep on making these videos on regular basis. With this, let's start today's video. In previous video, we have covered up to I think question number 26. Yes, this was the last question which we covered, and today we will start with the next one. So let's adjust pen's width slightly and start. The length of a given cylindrical wire is increased by 100% due to consequent decrease in diameter. The change in resistance of the wire will be. So here it is mentioned that length is increased by 100%. Means suppose initially you have length is equal to L. So now it becomes L plus L or equals to 2L. Now, in one of our previous questions, we have already discussed that if length changes by volume of wire or material, volume stay constant, and also material is same, then what happens? Then we know that the resistance, the final resistance or the new resistance comes out to be n squared times of old resistance or initial resistance, where n is defined as ratio of final length to original length. So final length is 2L by initial length is L, so 2L by L whole square into R initial, so R final comes out to be 4 times of R initial, and delta R or change in resistance is 3 times of initial resistance, or we can say it has been increased by 300%. So change in resistance will be 300%. Option D will be the right answer. Moving to next question. In a given circuit diagram, wire is joining the points B and D. The current in the wire. So we have to find out the current in the wire. Now, as we can see, first of all, by seeing this diagram, we can assume it is a vein bridge. So first we have to check that it is balanced or not. Because if it is balanced, then current from B to D will be zero and potential at B and D will be equal. So to check the balancing, 1 by 4, the ratio of these two resistances will be 1 by 4, and the ratio of these two resistance will be 2 by 3. And we know that 1 by 4 is not equal to 2 by 3. So bridge is not balanced. So what does it means? It means there will be some current flowing in the from B to D. Now to find value of that current, we have to use basic we can say basic current analysis, or we can say the voltage, Kirchhoff's circular law and Kirchhoff's current law. We have to use all of these, and then we will be able to solve this. So first let's redraw the diagram. Here we have 1 ohm and here we have 4 ohm. Both of these are in parallel, and again we have 2 ohm and 3 ohm again, and again both of these are in parallel. 2 and 3 are in parallel, 1 and 4 are in parallel, and here we have 20 volt supply. Now as these are in parallel, so we can simply represent by a single resistance, and resistance of that resistor will be given by, for both of these, suppose final resistance for both of these is R. So 1 by R will be equals to 1 by 1 plus 1 by 4. 4 will be the LCM, 4 plus 1, and from this R comes out to be 4 by 5. Now let's suppose the resistance of both of these parallel combination resistors will be, suppose X, so 1 by X is equal to 1 by 2 plus 1 by 3, LCM 6, 3 plus 2, and X will be 6 by 5. So we can reduce our circuit such like it will be 4 by 5 ohm and it will be 6 by 5 ohm, and we have a potential connected here, battery 20 volt. Now again both of these two are in series, so again we can reduce this circuit further by adding both of these and forming a single resistance, and value of that will be 4 by 5 plus 6 by 5, that will be 10 by 5 or 2 ohms. So this whole circuit can be represented by a single resistance of 2 ohm with connected with a battery of 20 volts. Now from this we can find the value of current flowing in the circuit. Suppose if I current flows here, then the value of I will be 20 by 2 or 10 ampere. Now if I current is flowing through this circuit, then I current must be flowing through this circuit again. And as both of these 4 by 5 ohm and 6 by 5 ohm are in series, so their current will be the same. In this resistance also value of current will be I, and for this resistance also value of current will be I, because they are in series, and value of I is again 10 ampere. Now going back to the original circuit, as in this circuit total current is 10 ampere, so in this circuit again total current should be 10 ampere. Total inward current should be 10 ampere and total outward current should be 10 ampere. Now what we do? Now this 10 ampere current will be divided, because suppose this is junction A, as it is already mentioned that this is junction A, and here we have point B and C. So let's suppose this is B, this is D, and this is C. Now at point A, this 10 ampere current is divided into two parts. Some of this goes through 1 ampere and some of this goes to 4 ampere. And that values of those current we can easily find. That value of current passing through 1 ohm resistance will be given by, as 1 and 4 are in parallel, so in case of parallel resistance we take the opposite value of opposite resistance to calculate the value of current going through the actual resistance. So we are calculating here for 1, so we will take value 4. So 4 by total resistance, 4 plus 1 5 into current, total current, that is 10, so this will give us 8 ampere. Now similarly for I of 4, that should be, because total current is 10 ampere and 8 ampere is passing through 1 ohm, there should be 2 ampere. And let's calculate. Now for 4 ohm we will take the opposite resistance 1, so 1 by total resistance 5 into 10 is equal to 2 ampere. So from this 2 ampere current is passing. Now again these two currents will combine here and will reach here. Again it will be 10 ampere. Now out of this 10 ampere, how much will be passing through 2 ohm? So I of 2 will be 3 by 5 into 10, that will be 6 ampere. And similarly I of 3 will be 3 by, no sorry 2 by 5 into 10, so 4 ampere. So through this 2 ohm resistance we will have 6 ampere current, and through this 3 ohm resistance we will have 4 ampere current. So now we have solved the values of current. uh, Now let's zoom this circuit slightly, the original circuit, so that we can write the values. So yes, I think this color will be okay. So as per our what we have solved, now through 1 ampere, 1 ohm, there is 8 ampere current. Through 4 ohm, there is 2 ampere of current. For 2 ohm, there is 6 ampere of current, and for 3 ohm, there will be 4 ampere of current. Now, if you see carefully, this 8 ampere current, after passing through 1 ohm resistance, has to split into two parts, because only 6 ampere is passing through 2 ohm. That rest 8 ampere, rest 2 ampere of this 8 ampere should go downwards. Only then at this point B total current will be zero, because we know at any junction, according to Kirchhoff's law, that total current is always zero, or total incoming current should be equal to total outgoing current. As point B, at point B, incoming current is 8 ampere, and we have already solved for 2 ohm resistance that outgoing current is 6 ampere, so downward current should be 2 ampere. And that also matches with here, as at point D, incoming current from the 4 ohm resistance is 2 ampere. Incoming current from the point B will be 2, and outgoing current is total 4. 2 plus 2, 4. So it also balances out here. So as per asked in the question, that we have to find current in the BD wire BD. The current in BD wire is 2 ampere, which we have solved. So option B will be the right answer. Moving to next question, and let it make slightly thicker. The series combination of two batteries, both of same EMF 10 volt but different internal resistance 20 and 5 ohm, connected in a parallel combination of two resistance 30 ohm and R ohm. Voltage difference across the battery of internal resistance 20 ohm is 0. Value of R we have to find out. So initially we have a series combination of two batteries. So suppose this is our first one battery with its internal resistance 20 ohm, and its potential is 10 volt. Now we have another battery of same 10 volt potential with internal resistance of 5 ohm, and they are connected to parallel combination. So this is our parallel combination. This is 30 ohm, and there is another resistance in parallel with this, that is R ohm. Now voltage difference across the 20 ohm is 0. Voltage difference across the battery of internal resistance 20 ohm is 0. So we are measuring potential difference from this point to this point, and this is coming out to be 0. Now we have to find out the value of R. So to solve this type of questions, First of all, forgot what is given that voltage difference is zero. Just simply assume that there is some current flowing in the circuit, and we will consider this part later, this condition later. Now we simply assume that there is a current flowing in the circuit, and that current is suppose is anti-clockwise. So current is flowing something like this. This is I current, and this will I will split here into two parts, and again this will be the value current I, and this will be the positive side, because the direction in which current flows gives positive and negative to resistances and capacitors and inductors also. So this will be positive, this will be negative, this will be positive, this will be negative. This will be positive side for this resistance, negative side for resistance, positive side for resistance, negative side for resistance. And for battery, direction remains as their terminal. So for this battery, this is negative terminal, this is positive terminal. For this battery, this is negative terminal and this is positive terminal. So first of all, let's find out total resistance of the circuit. So both of these are in parallel. So their total resistance will be 1 by 30 plus 1 by R, and this will give us 30R, and this will be R plus 30, and from this RT, total combination, total resistance of both of these in parallel will be 30R by R plus 30. Now total resistance of circuit, that will be 30R divided by R plus 30 plus 5 plus 20, so plus 25. So we can say resistance of circuit is equal to resistance RT, which is parallel combination of both of these, plus 25. Now let's apply Kirchhoff's voltage laws, or let's take a closed loop. Okay, I forgot. First, we have to find value of current. Then we will take a closed loop. So I will be, now both of these are battery are in series and their negative and positive are connected. So their potential will be added. So 20 divided by total resistance, that will be RT plus 25. So now we will apply uh, Kirchhoff's laws of potential. Now suppose this is our point A and this is our point B. Now as per mention, that potential difference both of these point is zero. As per mentioned, voltage difference across the battery of internal resistance 20 ohm is zero. So for that, we will start with point B. So suppose there is some potential at point B, and we name it VB. Now we will move towards this resistance of 20 ohm. So plus minus. If you are going from positive to negative, we take it negative, and if we take going from negative to positive, so we take the positive. Or we can say in the direction which we are moving, we take the second sign, not the first sign. So first sign here is positive and second sign is negative. So for this resistance, we will take negative. So negative 20 into its current, because I is the current flowing through this 20 ohm. So minus 20 I. Now for battery, we first encounter negative, then encounter positive. So we will take positive plus 10 should be equals to, as we have now reached to point A, so this should be equal to point VA. And from this we can write VB minus VA should be equals to 20I minus 10. And as it is already mentioned that both of these points, the potential difference between both of these points is zero. So this should be equal to zero. So 0 is equal to 20I minus 10. And from this, I comes out to be 1 by 2. Now if I is equal to 1 by 2, now we will use this value here. So 20 divided by RT plus 25 is equal to half, and from this RT plus 25 is equal to 40, and from this RT is equal to 15. So total resistance or RT is equal to 15. Now using this value here, so 15 is equal to 30 R divided by R plus 30. We will get here 2. So R plus 30 is equal to 2R, and from this R is equal to 30 ohm. So answer here will be 30 ohm. So with this, let's move to next question. Current I in ampere flowing through 1 ohm resistance in the following circuit. So we have to find current through this I 1 ohm resistance. So not I, 1 ohm resistance. Now, as we can see from the diagram that this 2 ohm resistance and their combination, the combination of 1 ohm parallel combination plus series combination of 2 ohm, all of these are in parallel, and this 1 ohm potential is connected across this series combination. So here we can ignore 2 ohm resistance because both of these are in parallel, and when they are in parallel, then in case of an ideal power source, we can assume that this 1 volt battery can provide equal amount of or not, sorry, not equal, sufficient amount of current of to both of these. Suppose this battery had given some has given some power rating. Let's suppose it has a 5 watt power rating, then it can only provide a current of 5 ampere, and that 5 ampere has to be divided between both of these circuits. But as per now, though no power rating is given for this voltage source, so we can easily assume that it can provide sufficient current to both of these, this as a whole and this 2 ohm resistance. So we will not consider 2 ohm resistance here for our calculation, because we have to use only we have to find current only in the upper arm. So to solving for upper arm, both 1 and 1 are in parallel. So their series combination will give us zero point 0.5 resistance. Sorry, their parallel combination will give us zero point 0.5 ohm. And we have this combination in series with 2 ohm. And this is connected to a 1 volt battery. We are ignoring here 2 ohm resistance. So total resistance will be 2.5 ohm, and current I will be 1 by 2.5. So that will give us 5 by 2 or 2 by 5 ampere. So this will be the current I which will flow in this circuit, or which will flow from this. So I is equal to 2 by 5 ampere will flow through here. Now when I comes to point A, when current of 2 by 5 ampere reaches here, it has to split into two parts. Now as both of the resistances in parallel are equal, so it will split equally. So from the upper arm, current will flow 2 by 5 divided by 2, that is 4 by 5, and 4 by 5 is 0.8. Oh, it will not be 4 by 5. 2 get cancelled. So it will be 1 by 5. And 1 by 5 is 0.2 ampere. So option C will be the right answer. Moving to next question. A wire of resistance R is bent to form a square ABCD as shown in the figure. The effective resistance between E and C. So effective resistance between E and C we have to find out. And as per given that the total resistance of the wire is R. So for that what we can do, we can take total length as first slide it down slightly. Yes. Now as total resistance of wire is R, so each of arm of the square will have equal resistance, and there are four arms, so resistance of this arm will be R by 4, for this again R by 4, and for this R by 4. Now this arm is divided into two parts, and as mentioned that E is the midpoint. So resistance of these two will be equal and equal to half of the resistance of one arm. Now resistance of one arm is R by 4. So resistance for DE will be R by 8 and EC will be R by 8. So now we have all the resistances, and now we have to find out effective resistance between E and C. So between E and C, we have two paths. We can go via directly from E to C, or we can go from E to D, then A, then B, and then C. So E to C are connected via two paths, and both of these are in parallel. So suppose this is point E and this is point C. So they are connected by two paths. Resistance of one of the path is R by 8, and resistance of the other path, as all of these parts are in series, so it will be R by 4 plus R by 4 plus R by 4 plus R by 8. So this will be 3R by 4 plus R by 8 or 6R by 8, and it means 7R by 8. Now, as we can see that both of these are in parallel, so find the resistance, or we can say R total will be their inverse combination, sum of their inverse combination. So 8 by 7R plus 8 by R. 8 by R will be common. 1 by 7 plus 1, 7, 1, 7, 8 by R. So 1 by RT will be 64 by 7R, and RT will be 7R by 64. Option B will be the right answer. Now let's move to next question. A metal wire of resistance 3 ohm is elongated to make a uniform wire to double of its previous length. This new wire is now bent and its ends are joined to make a circle. If the 2 points on a circle make angle 60° at the center, the equivalent resistance between these 2 points will be. So this question consists of two parts. In first part, uh, that wire is elongated to double of its length. So here value of resistance will change, and now the new wire which is elongated is bent to form a circle, and then in that circle we will consider 2 points at 60° angle of each of other, and then we will find the effective resistance between both of them. So let's start the question, and we will do it by case wise. So case 1, that is elongation. The spelling might be wrong, so no problem, bear with it. So our length is increased from L to 2L, and as we know that if length is increased n times and volume and material remains the same, then resistance becomes, or we can say final resistance becomes n squared times the old resistance, and where n is ratio of final length to original length, and here it will be 2. So R final will be 2 square into original resistance, that is 3, so 12 ohm. So resistance of our new wire will be 12 ohm. Now let us consider a circle, as it is mentioned that this wire is bent to form a circle. So suppose we have our wire which has a resistance of 12 ohm is bent to form a circle, and here we have to consider 2 points. Suppose this is point A and this is point B, and they are at a 60-degree angle from each other, so their angle is 60 degree. So this angle is 60 degree, and total length of this wire is equal to 2L, or its circumference is equal to 2L, or we can say easily say that 2L is equal to 2 pi into its radius. This formula will hold here. Now as we know that for these 2 points A and B, they are connected via two paths. First directly A to B, and then overhead. Suppose we add some point here, C. Then from A to C, then C to B. So what we will do, we will find resistance of both of these parts, and then we will just do a parallel combination of both of these, because now A and B are connected via two paths, and both of these paths will act as a parallel resistances. So now total resistance of this circle wire is 12 ohm, and we are only taking a 60-degree portion of this wire. So we can say that 12 ohm resistance is across 360-degree angle, or 360 degree of angle covers 12 ohm of resistance, and 1 degree angle will cover 12 by 360 degree, as we have only 60 degree here, so 60 degree will cover 12 by 360 into 60 degree, 6 to 2 ohm. So resistance of this path will be 2 ohm, and resistance of the remaining path, because total resistance is 12 ohm, so resistance of this path will be 10 ohm. Now we can make a parallel combination of both of these. This is point A, we have a 10 ohm resistance here and 2 ohm resistance here. Both of are connected in parallel, so this is point B. Now their parallel combination will give us 1 by 2 plus 1 by 10, 10 LCM, 5 plus 1, 6 by 10, or inversing it, we will get 10 by 6, that will be 5 by 3 ohm. So that will be the final answer. Option C is the right answer. Moving to the next one. So in the figure, what is the current in ampere drawn from the battery? We have given values of all the resistances. So let us write, this is 15 ohm. Let me take a proper, this is 15 ohm. R2 is 10 ohm. R3 is 20 ohm. R4 is 5 ohm. R5 is 25 ohm, and R6 is 30 ohm. Battery is 15 volt, and we have to find the current drawn from the battery. So effectively what we have to do, first we have to solve this circuit and find the effective resistance, and then using that effective resistance we can find out the net current flowing from the battery. So let's start. As we can see that this 20 ohm, 5 ohm and 25 ohm, all of these three resistances are in series. So their parallel combination will give us 25 plus 25, 50 ohm. And circuit can be represented as something like this. Here we have R1, here we have R2, and here we'll have R6. And as we have taken combination of R3, R4 and R5, so the combination resistance will be in parallel with R2 with value of 50 ohm. So circuit will reduce to something like this. This is 50 ohm and this is 10 ohm. Now both of these are again in parallel, so their parallel combination will give us 1 by 10 plus 1 by 50. So 55, 1, 6 by 50, our effective resistance will be 50 by 6 ohm. So this circuit will further reduce to, here we have R1 that is of 15 ohm. Parallel combination of both of these will give us 50 by 6 ohm. And here we have R6 that is 30 ohm. Now 15 ohm, 50 by 6 ohm and 30 ohm, all of these are in series. So their series combination will give us 45 plus 50 by 6, 15 plus 30, 45 plus 50 by 6. So we can cancel it out on 25 by 3. And now 3 will be LCM. 45 into 3, 5, 135 plus 25 as it is. So 0, 6, 1 by 3. So total resistance of the circuit is 160 by 3 ohm. Potential of battery is 15 volt. So current through circuit will be 15 by 160 into 3. And this will go on 3, on 3 and 2. So 9 by 32 amperes. So option C will be the right answer. Moving to next question. A uniform metallic wire has a resistance of 18 ohm and bent to form a equilateral triangle. Then the resistance between any two vertices of the triangle. So we have a triangle here. So let's suppose this is a triangle. Now, as per mention, this is an equilateral triangle. It means that length of each side is equal. So suppose this is point A, point B, and point C. Now, so length of the each side is equal, and total resistance of the wire from which we made this triangle is 18 ohm. And this 18 ohm is divided across three lengths of equal three sides of equal length. So each side will have equal resistance, and resistance of each side will be 18 by 3, that is 6 ohm. So this side will have 6 ohm resistance, 6 ohm resistance, and 6 ohm resistance. Now, resistance between any two vertices. So suppose we are finding resistance between A and C. So between A and C, we have two paths, one from directly A to C, and then second is via point B. As we go point via point B, then we connect this 6 ohm and this 6 ohm in series. So from A to C, we will have two paths. Resistance of one path will be 6 ohm and resistance of second path will be 12 ohm, as both of these are in series. AB is in series with BC. So this will look something like this: 12 ohm, 6 ohm, and here is point A and here is point C. So now we can find their parallel combination: 1 by 6 by plus 1 by 12, so 12, 2, 1, 3 by 12, or effective resistance will be 12 by 3, that is 4 ohm. So option A will be the right answer. So with this, we end this video here. Hopefully, whatever we have covered is helpful to you and has added some level of understanding to you. Again, if you find this video useful, then do press the like button, share video as much as possible, and subscribe to our channel. If you have any comments, doubts, or suggestions, then put them in the comment section. I will try to implement them or solve them. And also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be able to keep on bringing these videos on the regular basis. So again, thanks for watching, and we will meet in